Thanks to Thunderbird Perch for making this possible. Please like, subscribe, and share. The idea that the sky can be turned into a giant speaker sounds like science fiction. It is not. Modern science shows it is possible to make the upper atmosphere broadcast very low-frequency sounds. These sounds are so low they are below the range of human hearing. They are called extremely low frequency, or ELF, waves. Critically, these man-made atmospheric sounds fall in the same range as human brainwaves. This essay explores a bold claim born from peer-reviewed science. It argues that ionospheric heaters can be steered to generate specific ELF waves. These waves can match and potentially influence brain rhythms on a large scale. The question is no longer if the sky can be used this way, but how, and with what effects. The breakthrough that changed the game has a technical name: geometric modulation. Detailed in studies published between 2010 and 2014. A key paper in Geophysical Research Letters laid out the method, by Morris Cohen, Umran Inan, and Mark Golkowski, from Stanford University and the University of Colorado, Denver. They turned a blunt instrument into a precise tool. Previously, ELF was made by quickly pulsing the HF beam, effective but limited. It yielded broad, noisy signals, hard to make a pure note. Geometric modulation sweeps the beam in fast patterns, painting the sky. A moving heated spot forms a virtual phased array, steering a new ELF wave at chosen angles. Imagine the ionosphere as a giant dark canvas. The HF heater is a paintbrush of radio energy. We moved from jabbing one messy dot to controlled strokes. Draw lines, draw circles, draw patterns at incredible speed. The pattern and speed set the ELF wave's frequency and direction. Sweep in a line, get a dipole in the sky. Sweep in a circle, get circular polarization. Pick 7, 10, or 15 hertz. Clean tones, not a jumble. And crucially, the signal is steerable, east, west, or straight down. Ground receivers measured and verified the precise frequency and direction. The Earth has a natural electromagnetic heartbeat, Schumann resonance. Lightning excites waves trapped between the surface and ionosphere. The strongest peak averages 7.83 Hz, the Earth's hum. That sits right on the border between theta and alpha, the alpha-theta bridge. Theta links to deep meditation and creativity, alpha to relaxed alertness and flow. Some propose our brains evolved bathed in this stable planetary signal, a plausible natural tuning fork, a master clock aiding smooth state transitions. So what happens if a stronger, coherent tone arrives near that band? Geometric modulation can create signals precisely within 412 Hz. The physics enables it. Biology suggests a mechanism. The question is, how does the brain respond? Neural entrainment. The brain tends to sync its rhythms to a dominant external stimulus. You feel it with flickering light, repetitive beats, and pulsing sounds. A stronger oscillator can pull a weaker one into sync. If an ELF signal at ground level were strong and persistent, it could hijack that process. Introduce 8.5 or 10 Hz. Oscillators may entrain away from 7.83 Hz. Slight differences create a slow beat, the difference between the two. Example, 7.83 and 8.5 Hz yield a 0.67 Hz beat. That deep, slow wobble can disturb timing, not thoughts content, but the rhythm that supports them. Predicted symptoms: low-level anxiety, time distortion, loss of creativity, and shallower sleep. These symptoms have many causes, yet they match what low-frequency interference would predict. The view from orbit offers a control case. NASA probed every factor affecting astronaut health for decades: circadian disruption, poor sleep, immune changes, malaise. Inside spacecraft, crews are shielded from Earth's natural EM environment, including 7.83 Hz. This led to a question: could the absence of the Schumann field contribute to symptoms? Countermeasures were considered, including generating Schumann-like fields in habitats. Technical reports discuss EM environment importance, motivating Earth-like conditions in space. Within aerospace medicine, Schumann resonance is treated as a potentially significant factor. Space adds confounders: microgravity, radiation, extreme stress. Still, NASA's interest is a suggestive link. The Earth's hum may be vital to human physiology. What we know for sure: be precise about fact versus inference. 1. Ionospheric manipulation is proven. Geometric modulation was published in peer-reviewed journals from 2010 to 2014. Papers demonstrate coherent, steerable ALF waves from HF heaters. 2. The controllable range overlaps human brainwaves, 0 to 100 Hz. Delta, theta, alpha, and beta all live within that window. Schumann's 7.83 Hz lies squarely inside. 3. Neural entrainment is foundational neuroscience. Brains sync to rhythmic stimuli. 4. In controlled environments, removing the field correlates with negative outcomes. Together, they establish means, motive, and opportunity for large-scale ELF generation. A responsible inquiry highlights what is not known. No public, large-scale, double-blind human exposure trials link ionospheric ELF to anxiety or cognition. Ground-level strengths may be very weak after long travel. Local electromagnetic noise could swamp any man-made atmospheric signal. We lack transparent maps of real ground-level field strengths. Modern stressors offer powerful alternative explanations for rising anxiety. ELF bioeffects at very low intensities remain debated. The threshold for biological significance is not clearly defined. The path forward is transparent research, independent replication, and robust public oversight. Technical capability is proven. The biological pathway is plausible, evidence is suggestive. Definitive proof awaits open, rigorous science.